pretty much like the previous speaker, I have a bunch of slides and not a lot of time, so I'm going to try to get through some things. I have demos at the end for all of these things, permitting that we have time to do those. My name's Tom Gallagher. I'm a security test lead for Microsoft. Today I'll be presenting on finding and preventing cross-site request forgery attacks. This attack and a lot of related attacks are detailed in a book that I recently co-authored for Microsoft Press called Hunting Security Bugs. You can pre-order it now. It's going to be available on shelves next month. So why am I here talking to you about cross-site request forgery attacks? Basically, this is an attack that allows the attacker to take arbitrary actions against a website under a victim's permissions. So anything the victim can do against the website, if this bug exists, the attacker will be able to do that against the website. The basic way the attack is pulled off is very similar to cross-site scripting. However, it seems to be missed by many web penetration testers. If you read Bug Tracker Full Disclosure, almost every single day we see cross-site scripting reports. However, it's very rare to see a cross-site request forgery posting. Another thing about this attack is it's not a small coding error. Cross-site scripting is a failure to encode data that's being output to the HTML stream. This is a little bit more involved in fixing, and since fixing it is more involved, this is a lot of work, and so if you get hit by one of these bugs, you're not going to be able to turn around the fix in a few minutes or very quickly. And then lastly, this would be of interest to most people. There are related, this attack can happen in SOAP, although it's pulled off slightly differently, and it doesn't happen in all situations with SOAP. And I'll talk about when it applies and when it doesn't. So in order to understand this attack, we really need to understand HTML forms. So I'll do a quick refresher on this. When you're using a web application, you're usually presented with a form, and then you fill out some data on that form. So first you request something from the web server replies to you with a form, you fill that form out, and then the web server receives that request and then verifies that the user making the request is allowed to make that action. And then if he's allowed to perform that action, the web server goes ahead and performs that action on his behalf. So it doesn't seem like there's a security problem in doing this because, the action is only done once the user is authenticated and verified that he's allowed to make that action. So the crux of the problem is this. We have to remember, in order to understand this attack, we have to remember how the web browser security model works. There is cross-domain support in the browser. However, it's only on read access. So with that, for example, if we have www.contoso.com and it tries to read content from www.microsoft.com, the browser security model prevents this because it's attempting to read it. However, there is cross-domain posts allowed. So in this example, www.contoso.com can make a form submission to www.microsoft.com. So in the cross-site request forgery attack, the attacker coerces the victim to submit data that he's supplied to the target web application. So the anatomy of how this attack works. The attacker creates a form on his own web page and pre-populates that with form data that he wants the victim to submit. He coerces the victim to then browse to that form, and then that form is submitted to the victim's web server. This isn't very difficult to pull off. JavaScript can automate submitting forms. Then when the web server receives this request, it verifies that the person requesting it, in this case the victim, is allowed to perform that action, and then if he is allowed to perform that action is taken place on the server. So there are a few obstacles with pulling off this attack, and there are some ways that the attacker can overcome those obstacles. So first, you have to, if you're the attacker, I'm a penetration tester, so I say you. I'm not saying that you should be attacking people, obviously. So when someone's pulling off this attack, they need to know where to submit that data to. for the victim. So this is really useful in targeted attacks where you know something about the target and you know his web application that's going to receive this data. It could also be useful in attacks where there's a widely used website. For example, if there's a widely used bank site or an auction site or something like that, an attacker could put a form out, hope that a lot of people will hit that form, and then some of those people actually have accounts on that targeted website. So the next thing that the attacker needs to do is convince that user to load that web page. That's not very difficult either. Phishing tells us that lots of people are willing to load arbitrary web pages. And then lastly, this might be the most difficult part of pulling off the attack. The victim needs to log into the server. So, if the first two actions happen and the victim browses to a website, that website tries to make a form submission to another website, they might get prompted for credentials and realize that something's gone wrong and not supply those. However, in cases where automatic login can happen, like single sign-on, cookie authentication, Windows integrated authentication, this login process will automatically happen, and so the victim won't be really aware that this is occurring. So what I've discussed so far applies to post request, but it also applies to GET requests. And actually, it's a lot easier with GET operations. So in the HTTP 1.1 spec, it says that GET requests should only be used for retrieving data. However, in practice, this is not the case. Lots of people have URLs like the one mentioned on this slide. So it says, delete message.asp, and it supplies a message ID, in this case of 1. And so if somebody retrieves that URL, the first message would be deleted. This is really nice for attackers because any place a URL would be retrieved, they could supply this type of URL and get the action to automatically occur on the victim's behalf. So you can imagine an HTML email with an image source pointing to a URL like that. Message would automatically be deleted without the user's awareness in this case. So we're not here just to talk about how to pull off attacks, but also how to prevent them. So here are some common ideas for ways to prevent the attack. The first one is people commonly say, let's use the HTTP referrer. So the reason that they suggest this is because the malicious form is coming from a different site than the one receiving it. You could check and say, hey, that's not my site that's submitting the data to me. Then we would toss that request or say that there was some type of violation. This doesn't work so well because lots of privacy people will strip referrers and other things like that, and then they wouldn't be able to use your web application. The second one is to store state, and this can work in certain situations. However, it depends how you store state. If you're storing it on the back end, it's not going to work really well because what you would be doing is verifying that the user requested the form before they actually submitted to the form. And you could store this on the back end or in a cookie, and they have the same problem because the attacker could force the victim to load the form, not fill out that form, then load the attacker's form, and then after the attacker's form is loaded, then submit. The server would see that as, did they load the form from my server first? Yes, they did, and then you would still be in trouble. Another way to do this would be to store some type of state in a hidden HTML field that the attacker would not be able to predict. So if we did use this mitigation or protection of using a hidden HTML field to verify that the user is actually coming from the legitimate form site, there's some penetration testing that needs to occur on that validation field. The first and second tests that need to be checked are that hidden field cannot be predicted by the attacker and is unique for the user. So if the attacker goes up to the website, he would receive one of these hidden form fields. You want to make sure that he can't take that hidden form field out of the request that he received and put it in the form field that he's going to coerce the victim to send. So that covers the first two cases. The second one is you shouldn't be doing any GET requests that do dangerous actions. So any action other than retrieval shouldn't be done with a GET request. So sending, a validation field shouldn't happen on a GET. If you do this, you'll run into other problems because the referrer would then be sending the GET as well, and so the attacker might be able to get that information. Then the last test case that I'd like to talk about, it seems kind of obvious, but some people have run into this. If you just remove the hidden form field in some cases, then you might be able to bypass the check. And so some developers would look at this and say, I'm only going to put the validation field on forms that I want to check on. If it's not there, then I don't need the check, and then you bypass the check. And then, be really careful about what you decide you need to check the form validation fields on. We did threat modeling with one team, and they thought that the only dangerous action that their server application would take were database updates, and so they did all the checks right before they did a database update. It turned out that their web application could also send email on behalf of the user, and so there wasn't any check there. So you actually need to test every web page, not just one check for the entire site. So there is good news for people using ASP.NET. If you're using ASP.NET 1.1, there's a property called viewStateUserKey, and that will use the existing viewState hidden field property and make that unique for the user. So that covers all of the cases that I just discussed. So it's almost painless for the developer to do this. However, other languages like classic ASP, C++, PHP, to my knowledge, do not have any built-in protection for this, so you would have to roll your own protection, and that could be rather time-consuming. So the impact on SOAP. SOAP requests are a little bit different than regular HTML form submissions. A SOAP request, instead of having form data, it has XML as the payload, and it also has special headers saying that it's a SOAP request, for example, the SOAP action header. Unlike form submissions, SOAP requests are prevented from going cross-domain. So if you're using the XML HTTP object or similar objects in different browsers, they should prevent these cross-domain submissions. So you generally don't have this cross-site request forgery attack with SOAP. However, there have been some additions to SOAP in 1.2 that can allow all of the same problems that we just discussed. So there's this idea of get and post binding with SOAP. And what this allows someone to do is call into a SOAP method using regular HTML forms. So for example, if we wanted to use the get binding, this typically takes one of two forms. So in this example, we have a file called action.asmx. There's a method in that file called bid. It has two parameters, one called ID and one called value. And so this would make a bid in the amount of $1,000 for the item 5089. So if you think about this, this has all the same problems that we discussed earlier, where you could put this as the source of an image or any place where a URL, send that to the victim, and then when that URL is evaluated, that SOAP method would be called into. The first format is how ASP.NET does it, and a few other frameworks do it. Some other frameworks use the second format there. And then just like the get binding, there's also a post binding. It's identical in the way it works. The only difference is instead of sending the data on the query string, it's sent as the post payload. So when you have things like this, you obviously have all the same problems that you had before with the cross-site request forgery. So what can you do about that? In ASP.NET, there are two properties called HTTP post and HTTP get to toggle that. So you want to make sure that you have that disabled. And it is disabled by default. However, a lot of people debug using this functionality, so people might turn it on the server and forget to turn it off. If your SOAP framework doesn't have the ability to disable this stuff, you could go into your web server and configure that so that you're not allowing these requests. And then lastly, some people will allow the get and post bindings, but only if the request is coming from localhost. That mitigates a lot of the problem. However, it doesn't completely solve the attack, because the attacker could attempt to attack the administrator browsing from the web server, but admins really shouldn't be browsing from the web server anyway. So here's some ideas for automated testing. We want to test in the two big categories, the regular HTML forms and then the SOAP get and post bindings. So if you're testing HTML forms and you are working in a software vendor company and you have existing automation that tests all these web pages, what you can do is you can hook into IE or write a proxy or use one of the existing proxies to go and perform those test cases that I previously talked about and verify that the functionality does or doesn't work. For the SOAP cases for get and post binding, you can do a couple of things. Of course, you want to check the web.config or the similar configuration files to verify that you're not allowing this. If you have local access to the machine, you then want to go and find out what all your SOAP methods are and then try to form those get and post requests to see if they actually work. If you are a remote attacker, what you can do is request the WSDL file and then form the get and post request based on the information provided in the WSDL. Any questions? Okay. Yeah. I don't work on the browser team. I'm not aware of the browser handling this. This is only interesting in cases that, do some type of dangerous action and where the user's authenticated. There are many user scenarios where people actually want to do this. For example, if you have a search box on your site and you type something in there and click submit and it does a Google search, in that case, it's actually a GET request, but you can imagine the same functionality with the POST request. Any other questions? Okay. So I have this web application on my local machine that allows you to add users. In this case, I've loaded this is like the bad attack web page. But I left all the UI showing exactly what it's doing in a real case. The attacker would hide all this stuff. He would probably put it in an iframe or frame set that's like 1 pixel large, so you wouldn't really see anything. But the data's already pre-populated, that there's an account called bad guy and a password's in there, and that, of course, since he's the bad guy, he wants to be an admin as opposed to a guest or something like that. So if I click add user there, it tells me that, the bad guy has been added. The attacker wouldn't be able to see that information because that's a read. However, the action happens and the bad guy account has been created. So in this case, it's a local file that's doing the post to the website localhost. However, that file could live on any web server or be an email attachment. And then the other thing that I wanted to show is very similar. So again, this is a local file, and I can specify any user account. And in the attack scenario, the person would have this already filled out. Now, what this is a form that's saved that the attacker retrieved under his account. And when this is submitted, you see that ASP.NET caught this, and it said that the hidden form field was not correct. And that's because I didn't request that page. There's two pages that we're submitting to on this site. The first one is the correctly coded one. The first example was a buggy application. And so you see here that there's this view state, and that's the form validation property, and that's unique for each user. So the attacker wouldn't be able to get that and get a different user to submit the form data with that. Okay. Any questions? Okay. Well, thank you.